Hello, fun! My name's Nick, and I'm here at the Central Illinois Regional in Peoria with Team 2481 Roboteers. They've had an incredibly powerful season, ranking 7th in EPA in the world earlier this week. They just came off a clean 228-point score, and they have all sorts of unique mechanisms to make all of that work. All this and more coming up on Behind the Bumpers. Now we're going over to Andrew to talk about their custom swerve drive.
So in the off season, we had met this past season and decided we want to have a custom swerve now. We had run off-the-shelf modules for the past 2 seasons, and we noticed many things that we didn't like. It wasn't a true off-the-shelf because for what we wanted, we always had to have some sort of customization. So what we did first was we noticed that all the other wheels, they slipped a lot. So we have this nice larger wheelbase to allow more traction, and then we have more grip to the carpet, allowing more wheel odometry to be accurate. Then we also have a center hub that connects our 2 gears, so that if we want to gear it differently to go all the way from 14 to 32, we swap 2 gears and it's at what we need. Instead of going, oh, we need L2, L3, L4, it's a wider range of speed that we may need.
It's very interesting, thank you. Now we're going over to Levi to talk about their slide and shooter.
Yeah, so we decided to go with a mechanical alignment device this year. The reason we did this is because in 2019, we had some large success with our mechanical slide that we had that year as well. You can see it here. Jeez. It's run on an IGUS slide with the motor is back here. It's an X44 on a transmission that runs a chain on our slide, and it can move back and forth like this. And we use 2 limelights in the front of our robot that look at the April tags in front of the reef, and they're angled towards the reef so that we can see the April tags in almost any orientation, so that we're able to know exactly where we are. And then the slide logic happens inside the code, and it just automatically lines up even without any driver input. It also can auto shoot if it knows that all of its set points are correct and it's ready to shoot.
It's very cool. What led to the design decision to create a system like this? I don't think I've seen anyone else here with a system like it.
Yeah. So a lot of the inspiration, again, came from 2019. But as we were at the beginning of our season testing a lot of different prototypes and how we wanted our shooter to work, we tried a lot of passive alignment devices that would score automatically without any motor interaction, because those always can be a little bit faster. But we were struggling to come up with a design that would work. So we swapped to the design that we knew would work in 2019, which is a mechanical alignment device, which is able to just slide back and forth on a motor. And then we just iterated a lot in CAD to come up with a design with this IGUS slide and the chain running alongside the back.
It's very interesting. Now we're going over to Caleb to talk about their intake.
So this year we went with a ground intake because we discovered you could roll coral almost to the reef from the human player station. Meaning if you could pick up coral off the ground in any orientation, we would have significantly faster cycle times. Everything is run off of 1 motor, meaning we have no vertical rollers. And the way this is accomplished is through this guide wall here, which pushes the coral into 1 orientation every single time. The green wheel that you see eliminates the dead zone, and the solid bottom roller kicks the coral up when it's perpendicular to the roller.
That's very cool. Was there any particular strategic design in the process of creating this? I know your human player has shown an incredible skill of being able to throw that coral right out to the middle of the field towards the reef for you all. Was that a factor in your design strategy for this intake, or did that come up later?
A little bit of both. We knew we could throw it far, but we didn't know we could throw it quite that far. But we wanted to be able to pick up in any orientation just because of speed and simplicity. And the reason it's a ramp and also not vertical rollers is also for simplicity. So everything is powered off of 1 roller, and you can see the guide wall in work here. So as you can see, all of the rollers are powered by 1 motor spinning extremely quickly, and it allows us to force the coral into the single orientation we want, coming in from any orientation.
It's very cool. Now we're going over to Drake to talk about their climber.
So we knew that we wanted to do a deep cage climb because it would be worth most points. And our goal with this was to be able to hook the cage and bring it to the middle of the robot so we have the center of gravity. One cool thing about a robot is we actually have 2 ratchets on it to help hold it up because the motor actually wasn't strong enough to hold it up. So we put 2 ratchets on it, which actually keep it up And what we're able to do is release stress on everything else and bring the whole cage into the center of the robot at the angle and keep it into center of gravity.
That's really fascinating. I've seen it work very well today. Now finally we're going over to Matthew to talk about their elevator.
So this year we chose to go with a Cascade elevator. It's worked really well. We had to go through a lot of iterations and design changes to make it more durable, but we iterated off of past elevators that we've used, and that's been really good. Some design changes that we've had to make are the pulleys we made. We made custom pulleys because these are one piece instead of the 3-piece ones that you can buy. And other things we've done is we use belts and chains rather than some teams will just do one or the other. That helped a lot with weight. And we didn't buy one because of a lot of the design issues that worked with our robot. So when we're in a match, our robot will put up the elevator to L1, L2, or L3, which are all preset. So Levi's gonna give you an example of that. And then when we're scoring, if we're too far back, our cameras will see that, and the elevator will go up a little bit higher so that we still shoot it onto the peg.
That's all very cool stuff, and I've seen it work incredibly well all day today. Well, Roboteers, thank you so much for your time. I think you're doing very well. You're still holding on to that rank 1 as we're under 10 matches to go to the line selection. Again, thank you so much, and good luck for the rest of today.
Thank you.